In the previous video, we have used the various reference variables as the data member of a class. In this video, we will do some experiments on a case if reference variables of same class used as the static data members of a class. Namaste everyone, I am Gyan and you are watching the last video of the session 5 of Java and Web, user-defined data types. We already have seen this slide in the previous video. So let's start our experiment. If we try to print the value of m1.i, then we actually want to print the static variable I of class main using the reference variable m1. And you know from the previous video, we can do it. We can access the static variables using the object reference. So if we try to print m1.i, it will print 1. Similarly, if we try to print m1.j, it will print 2. If we try to print the m1.k, then it will print the instance variable k of an object whose address is stored into the reference variable m1. The variable m is the static variable of method main. So we can access the variable m by object reference. And since the variable m contains the address of new object, that's how printing m1.m will print the hash code of an object whose address is stored into the reference variable m. Of course, this reference variable m is a static variable. But this reference variable m contains the reference, the address of an object of type main. If we try to print the static variable I using the class name, then we know that we can do it. Since the static variables are common for all the objects, that's how we can access the static variables just by using the class name. And that's what we are doing here. We are printing main.i. That will also result in 1. Similarly, if we try to print the value of the variable main.j, then it will print 2. We cannot access the instance variable k by using the class name. So we cannot print main.k. But if we try to print the variable main.m, then it will print the hash code of this object. Since the reference variable m, which contains the address of an object of type main, itself is a static variable. So we can access this static variable, which is a reference variable, by using the class name. If we try to print the reference variable m by using the class name or by using the object reference, then it will print the hash code of this object, because the address of this object has been stored into the reference variable m. Now let's try to print m1.m.i. Let's forget whatever is written after m. Just consider on m1.m. So by writing m1.m, actually we are trying to access the static variable m by using the reference variable m1. So result of m1.m is this static variable. And we know that this static variable itself is a reference variable. Now after that, by using this reference variable, because the result of m1.m is this reference variable. So by using this reference variable, we want to access this static variable I. That's how by writing m1.m.i, actually we want to access the static variable I. If we print the m1.m.i, it will print 1. Next thing to print is m1.m.j. Similar to the previous example, by using the m1.n, actually we are accessing the static variable m by using the reference variable m1. But the static variable m itself is a reference variable. So by using this reference variable, we are accessing the static variable j, which will print 2. If we try to print m1.m.k, by writing m1.m, we are trying to access the static variable m by using the reference variable m1. So the result of m1.m is this static variable, which itself is a reference variable. And then after, by writing m1.m.k, actually we are trying to access the instance variable k of an object whose address is stored into the reference variable m. So by writing m1.m.k prints this k. If we try to print m1.m.m, then first just focus on m1.m. By writing m1.m, actually we are trying to access the static variable m of the class main by using the reference variable m1. And then by using the reference variable m, we want to access the static variable m, which is the same variable. So by writing m1.m.m, we end up accessing this variable only. So by writing m1.m.m, we print the hash code of an object whose address is stored into the reference variable m, where the reference variable m itself is a static variable. Now this is another case. We want to print m1.m.m.m. By writing m1.m, actually we are trying to access the static variable m by using the reference variable m1. But this static variable itself is a reference variable. So for the second dot, actually by using this reference variable, we want to access the static variable m, which is this variable itself. And for the third dot, we want to access the static variable m by using this reference variable, which is again same reference variable. So by writing m1.m.m.m, actually we are trying to print the hash code of an object whose address is stored into the reference variable m. And similar is the case if you write the class name main instead of reference variable m1. So it does not matter how many times I am accessing the static reference variable m by using the reference variable m1 or by using the class name main. It will end up accessing same reference variable m. So if you try to print m1.m.m.m.m.k, it will print this 0. If you try to print the main.m.m.m.m.m.m, it will print the hash code of this object. If you try to print the main.m.m.m.m.i, it will print the 1. So it does not matter how many times I am accessing the static variable m by using the reference variable m1 or by using the class name main, it will end up accessing the same variable m. And by using this reference variable m, we can access I, we can access j, we can access k, or we can access the same reference variable m. The similar thing happens when we call main.m.m.m. By using the class name, we are accessing the static variable m. This static variable m itself is a reference variable. So by using this reference variable, we again call the static variable m, which is the same variable. Again by using this reference variable, we call this static variable m, which is the same reference variable. That's how by writing main.m.m.m, actually we are trying to print the hash code of an object whose address is stored into the reference variable m. In this example, we have printed all the various values. This is a task for you to apply this code practically. So this was the last video of the session 5 of Java and Web user defined data types. Don't forget to like and share this video, subscribe this channel if you are new, and leave your valuable comments in the comment section below. Thanks for watching. See you in the next session of the Java and Web constructors.